we're going to continue here with talking about how spread out data is. And don't you worry, in the next video, we're going to start adding some pictures to this. So how spread out a data set is measured several ways. It could be measured by the interquartile range. It could be measured by the range. Could be measured by standard deviation. So let's talk about each of these. The range, by definition, is the maximum minus the minimum. So it's the max minus the min. All right, so the speeds have a range of 59 miles per hour. It's quite a big difference. Now, the standard deviation, if you type standard deviation, it is ST. There's a standard deviation, population, and sample. We're going to be taking the sample standard deviation in this class. And the sample standard deviation is 12.03, and standard deviation is average distance from the mean. So, on average, the speeds differ from the mean of about 76 miles per hour by 12 miles per hour. So a lot of the means a lot of the speeds will be within one standard deviation of the mean, between 64 and at 88 miles per hour. And so that's what the standard deviation is measuring, is how spread out the data set is as far as how it compares to the mean. So on average, the average distance from the mean is 12 miles per hour, but there's a total of 59 miles per hour of difference. Now, the interquartile range is the difference of the middle 50%. That middle 50% is the third quartile minus the first quartile. See, the third quartile is bigger than 75% of the data. The first quartile is bigger than 25% of the data. And so this captures the middle 25% or 50% of the data. That's quite small. The middle 50% of the data is spread out by only 10 miles per hour. So though the entire data set is spread out by 59 miles per hour, the middle 50% is only spread out by 10 miles per hour. So that's telling us that the upper and lower parts are accounting for a lot of the spread. And we said earlier, the lower part is really being spread out slowly. Now, there's a way of determining what an outlier is. Like, those are numbers that are really big or really small in the data. And I want to tell you how Excel is going to determine an outlier. An upper outlier is a big number. And it says a number is big if it's the third quartile plus 1.5 times the interquartile range. That's the definition of an upper outlier. And the lower outlier is really small, so it's going to be the first quartile minus 1.5 times the interquartile range. So those are the definitions of outliers. And what we see here is that the upper outlier cutoff is 95 and our maximum is 96. So there are upper outliers. The cutoff for a lower outlier is 55, and anything below that is an outlier, and the minimum is 37, which is a far below. It seems like there are some really big lower, some really, I'll say, extreme lower outliers, because to be a lower outlier, you just have to be at 55, and we have a value that's at least at 37. All right, so these are happening. What does it measure? These are measuring, are there outliers? And so we have some measures of center, some measures of spread. We see if there's outliers, and in the next video, we'll put some graphs to this.